All right. Today is the 10th of April. We're doing POTD. 10th of April 2026. Um, so we have an easy problem, which is nice. Hopefully get this one quickly. 3740, minimum distance between three equal elements. Number one. So there'll probably be might be a brute force version. You're given an integer array nums, a tuple ijk of this three distinct indices is good if nums at I is equal to nums at j is equal to nums at k. Sure, if the values in nums are equal. Sure. So, yeah. The distance of a good tuple is the absolute difference between, the first two indices and so the pairwise differences, absolute. So the distance between the sum of the differences between the pairwise indices. Return an integer denoting the minimum possible distance of a good tuple. Return an integer denoting the minimum possible distance of a good tuple. Okay. So since there's only 100 elements, you could definitely brute force this. Do I want to I guess I should, right? All right, I'll brute force it straight up because I think sometimes if I get too caught up in trying to be clever, I end up getting confused. So yeah, if we take an example, the minimum possible distance between a good tuple. So the priority is to look for equal elements that are close together because then the differences will be small. So if I take this first example, 3740 POTD. So as an example, if I have 1, 2, 1, 1, 3, 1, 2, 1, 1, and 3, 3, then the indices in turn are 0, 1, 2, 3, and 4. So the indices that we care about are 0, 2, and 3 because they hold the equal values. So we have, what's the term they use? The distance. The distance is equal to 2 minus 0 plus 3 minus 0 plus 3 minus 2. So we get 2, 3, and 1, so we get 6. That's the idea. And then naturally, if you have multiple options like that, then with indices 0, 1, 2, 3, 4, 5, and 6, you have two options. You can either have the 1s or you can have the 2s. So if we test it with the 1s first, distance for the red is 1 minus 0 plus 5 minus 1 plus 5 minus 0. 1 plus 4 plus 5 gives me 10 versus the blue distance, which would be 4 minus 2 plus 6 minus 2 plus 6 minus 4. So we have 2 plus 4 plus 2 gives me 8. So if we take the smaller one, we get 8. Fair enough. And if there isn't enough numbers to get a good tuple in at all, then if there is no good tuple because there's not three positions that have there's not at least three positions which have equal values, then return -1. So a couple of edge cases we can get rid of straight away. If the length of nums is less than 3, we can immediately return -1. If there's one element, two elements, then no point in doing any extra work. Let's get rid of that case. And then from there, min distance is equal to a big number, float infinity. For I, so we'll say n is equal to the length of nums. For I in range, so we can do a triple for loop, right? Up to n, for j in range, I plus 1 up to n, for k in range, j plus 1 up to n. If nums at j is not the same as nums of I, then continue, no point, and oops, if nums at k is not equal to nums at j, same thing. Otherwise, at this point, we know all three values are the same, all three elements at I, j, k are the same, so we can test. If absolute I guess k will always be bigger, right? So if k minus j, can I say, I'm not sure, is equal to I minus j, and k minus j is equal to, sorry, it should say j minus I, shouldn't it? J minus I, and k minus j is also equal to k minus j is equal to k minus I. Then obviously, if these two are true, then obviously j minus I will be equal to k minus I. Then wait, what am I doing? No, this is wrong. What am I doing? Sorry, I forgot what the goal was. If this thing is less than the min distance, then the min distance, oh, I don't have to do this, do I? I can just say min distance is equal to the minimum between min distance and this value. This is like the better way of doing it. Look good? Too many brackets? Okay. And then simply return min distance. Alright, let's just make sure that we have like, just want to make sure that we get the -1 result in different cases. Ah. Wait, what? It didn't return float of infinity? If, so yeah, I forgot to do this. If min dist is equal to float infinity, then return -1, because we never found a valid tuple. Otherwise, we should be able to just return it like that. I'm surprised it returned null. I would have thought it would return. Alright, I think this is good. I don't know where this would go wrong. I mean, I did make a mistake, but there we go. Okay, so quite slow. I would imagine that that's because people are doing it the more efficient way, not the brute force way, but I could be wrong. I don't want to look at the solutions in case that spoils it for tomorrow's problem. I assume tomorrow's problem will be part 2, where the constraints will be bigger. This one, the constraints will be bigger. Do I have any ideas on how to make this cleaner and more efficient? Because naturally it's an n-cubed solution, which works because the constraints are small, right? N is almost 100. But let's think about what we did. The goal is to look for what if we keep track, if we use the hash table, we should be able to sort of keep track of where the 1s are, where the 2s are, and where the 3s are, right? So let's think of it like that. So let's say I construct a hash table. I'll write this down. So let's say we construct a hash table such that ht at a particular value or a particular key is equal to a list, sorted list. I shouldn't say, maybe like I1, I2, etc., where nums at each I value is equal to k. So we're basically constructing it such that you get a list of the positions where k exists in nums. So we'll do that. So get rid of all of this. So for I, wait. Default dict, how to, I've used a counter before. I want to know how to use this thing as well. Okay. What? Oh. Okay, yeah. I think this is what I want. Okay, so I need to import this guy. It just handles the logic of like, oh, have I looked at this? Have I had this key before or not? Without me having to actually do anything. So like, we'll say value positions is equal to this guy, and then value positions is equal to that, and then for I num in enumerate nums, value positions. Do I just access it like that? Okay. At num dot append I. So now, if that num hasn't been seen before, it will first create the empty list for the I to be appended to, the index to be appended to. So these are sorted lists. So in this example, what will it look like? Well, I have 3 keys because I have 3 distinct elements. And then I have 0, 1, 5. I have 2, 4, and 6, and I have 3. So if I iterate through the keys, if the list length is less than 3, then don't bother, right? Otherwise, I have a sorted list of n elements, and I want to figure out which 3 elements have like the smallest distance metric thing. Okay, it's probably like a There's no point doing an n-cube thing at this point because might as well just do the n-cube thing in general, so don't brute force it. So otherwise we need to figure out the smallest distance available from these numbers. So let's say, for example, we have a list that looks like, 1, 4, 7, 12, 13, 15, 26, 28. So like there's some value, let's say a 2, and that 2 exists in all these positions in nums, right? So we want to figure out which 3 numbers we should use, which 3 positions in here we should use to make the smallest distance. And I think the advantage of doing this, as opposed to just like the original question, like through the brute force method, is you have a sorted list, which should be helpful. So we know, for example, that like if I look at the very first element and the very last element, they're going to be like super far apart, right? The goal is to minimize k minus j plus j minus I plus k minus I, where j, k, I, j, k are positions, are these values, are position values. We want to minimize that. So surely it would be a matter of just like looking at these window sizes of 3, because Is that right? Because, like, the distance between you is always going to be smaller than the distance between you. So there's no point in checking, I've done it, it's right, I have full faith. The distance between 1 and 4 is always going to be smaller than the distance between 1 and 7. In the sense that, like, generically speaking, the distance between this guy and this guy is always going to be smaller than the position between this guy and this guy, because it's sorted. It's in a sorted order. So it's in linear time, I'm able to determine the smallest element in the smallest distance metric by looking at which window of size 3 gives me the smallest distance metric. So yeah, this is linear time. So I don't know, I think this is still O of n squared, but because it's like this takes O of n time to construct this, and then for each distinct element, let's say there's a length of size n, let's say nums has length n, right? Then what? Then say each element appears, each distinct element appears like n times? No, the thing is, like, if each distinct element appears n times, then obviously there'll be n keys to go through, but then each list will have a size of 1, so that's also O of n. I think it should be n squared though, right? The time complexity should be n squared. Say each distinct element appears n on... Okay, let me say this again. Let's say there are d distinct elements, and let's also say each distinct element appears, let's say, I don't know, k times or something. Therefore, n is dk, time complexity is O of n, plus, this is the construction part of the hash table, plus O of d times number and how many times it appears. So, maybe it is linear then. Okay, cool. How many distinct elements you're iterating through times the number of elements, number of times that element appears. So maybe it is order of O of n. Okay, cool. So we've done it in linear time, I think, if that is valid working. So do I know how to do this? For num in value positions dot keys. Does this have keys in it? Do you default? I'm assuming it just like takes all the same it takes the same interface. Yeah, okay. Positions is equal to the value positions at this particular number. And then if length of positions is less than 3, then continue. Otherwise, I equals 0, while I plus 2 is a valid index. So hang on, I still need my min. I need my min answer. Min distance is equal to float infinity. I can still do my checking. If the length of nums is strictly less than 3, then return -1. While I plus 2 is less than length of positions, if positions at I plus 2 maybe I'll say, I don't know, call this pointer, and then can I say ijk is equal to, yeah, I can surely, positions, pointer, positions, pointer plus 1, positions, pointer plus 2, and this should work because we're making sure that pointer plus 2 is valid. And then min distance is equal to minimum between min distance versus the thing j minus I plus k minus j. Oh, I keep on equal. I can't type. Plus k minus I, and then do that a bunch of times, and then return min dist. If I know that ternary operator is a thing, it's just they write it weird. If min return -1 if min dist is equal to float infinity, else return min dist. So I think you can write it like this instead. Oh, I forgot to do this. I forgot to do that. I used a while loop? Yeah, fair actually, because it's like not quite the same. Because the condition's kind of weird. I've got a +2 in there. Yay! Come on. So tomorrow, so if I copy this entire thing and go to part 2, minimum distance between 3 equal elements. Minimum distance between 3 equal elements. Wait, what? Is there not a part 2? Oh, it's because I was looking at what I. There we go. It's a medium problem because it's now 10 to the 5, I assume. Yeah, so linear time is more demanded. Oh wow. More test cases. Wait, was there more test cases? What was the different? Wait, let me go here. Yeah, interesting. There must have been. Oh no, still just about as much. Might just be. I got on, of course, because the test cases are bigger, of course. I'm silly, sorry. Interesting. So I can cheat, right? Like, I mean, I'm not cheat. I mean, I already did the problem. Okay, so min length. Fair enough. That's probably better than using float infinity. Last indices, -1 times min length. What? You did 2 times min distance? Min distance is equal to math infinity? Oh no, wait, you did, yeah, you did. Okay. Last indices is equal to -1 times min length. Second to last indices is equal to -1 times min length. Huh? Min dist is equal to math infinity. Okay, so they are using math. They are using infinity. For I num in enumerate nums, if it's not -1, that indicates that we have seen that number twice, I assume is what this is saying. Distance is equal to I minus second to last indices num. Hey? Is this the first time we see the term distance? Yes. Wait, you don't even use distance. Oh no, you did. Sorry. So wait, but so your distance value is you're only using two Second to last indices. So maybe this stores like the distance so far or something. So distance is equal to I, the current I value, minus the second to last index. If min distance is greater than distance, then min distance is equal to distance. So yeah, like if this is true, then you're kind of saying that you've already seen, this is the third element you've seen, and it's time to do an update. Second to last indices at num, last in num, okay, yeah, so this is saying, what is the most recent time you've seen it, which is I. What is the second recent time, like, which was originally stored here, now you're putting it here. I don't fully understand, because you're only really 2 times min dist. Like, where did this come from? What? Did I misunderstand? Like, why are you doubling? Eh? If second to last indices num is not -1, that is, we have seen that element. Oh, wait, I kind of get it. Yeah. No, I don't. What? So second to last indices at this point is actually the first last index. So you're almost like caching the, okay, so you're kind of like keeping track of the most, you're doing the same thing, but you're doing it in less steps. Rather than constructing the hash table and then like filling it in the way I did it, and then sort of processing all the positions of each distinct element, you're kind of wrapping it all into one loop by using 2 arrays instead of using a hash table which stores all the positions. You're kind of just keeping track of what is the third most recent element, what is the second most recent, and then I refers to the most recent. So second to last, after you see the new I, second to last actually refers to the first, and last refers to the second, I think. But I don't really understand why distance can be calculated with just I minus, like this only looks like you're calculating one part of it. Like I thought you'd have to say I minus second to last plus I minus last plus second to last minus last kind of thing. Or maybe last minus second to last. I'm kind of getting tripped out. But yeah, I think second to last would have the smaller numbers, right? Because they're seen earlier. You know, like why is distance only this much? And also, why are you doubling? Let me see if there's any. Okay, I think these guys did it similar to how I did it. Okay. I want to see if there's any solutions that do this doubling thing. Return, no. This, like, I've just stumbled across this really random thing. Why do you double? Like, it seems like you're only finding with like a one part of the distance rather than. Yeah, I don't know. Alright, whatever, it's fine. No need to overcomplicate. I would really like to read as to why this works. Let me see if there's anything, if it's like over here. See, like, look at that. Oh. There's some trick I'm missing. The really fast, like, I'm assuming people around my time do something similar. Yeah. Yeah. that's clever. Yeah, these guys do something similar. Oh, this guy has a times two. Hang on. Wait, what? Oh my goodness. I get it. K minus I, J minus I, K minus J. The J's cancel. It's the same as 2K minus 2I, K minus I times 2. Oh, I didn't even see that. So you don't actually have to... Yes, so long as you have a J index, it doesn't matter what it is. So long as you have 3 elements, that's why they had to make sure first. So second to last is referring to, well, what I'm using is I. That's kind of confusing. What they're calling K, what they're calling I, I'm calling K. What they're calling second to last, I'm calling I. But it does translate. Ah. I didn't even clock that at all. I fully was just like, oh yeah, I have to add 3 things together. That's funny. Okay, fair enough. Now I get it. Yeah, this is cool. This is clever. Fair enough. See? So what happens. I see a formula, I just plug it in. I don't think hard enough. Okay, fair enough.